Welcome to another edition of the AMSAT Newsreel.
Has held his current position since 1991. He is one of two ARISS USA delegates and is the international chairman of the ARISS International team. He'll be assisted today with this presentation by Mark Steiner, K3MS.
Thank you, Barry, and good morning, everyone. I'm going to talk about where we are in the human spaceflight arena. We've got a lot that's happened in the past year, and we've got a lot in an exciting future here. So wanted to kind of give you a little status where we're at to date. How many of you do not know about the ARISS program? Okay, good. We have somebody that's honest. I'm going to quickly go through. I realize there's a lot of you that do know about it. I'm going to quickly go through a little introduction and then move on. Those of you that have been around a while know that the very first human spaceflight activity was Owen Gary at W5LFL in 1983 on the space shuttle. And since that time, we've done a lot of different operations. We were frequent flyers on the shuttle. A lot of operations, both on the Russian and the U.S. side on the space station Mir, and of course now on the International Space Station. And you know, the objectives of the program are many-fold. From an AMSAT perspective, getting people interested in amateur radio is a big thing, as well as the whole aspect of experimentation. But there's also this very important piece. Amateur radio is a hobby where we'd like to get more youth involved, and getting students interested in science and technology and communications, ham radio activities, is another very important facet of the ARISS program. Actually, it's one of the cornerstones of the ARISS program. And we're doing this in an international forum where we've got a lot of international partners in the major regions of the United States, Canada, Russia, Europe, and Japan that are helping pull this whole thing together in an international working group called ARISS. And the working group includes IARU member teams, which are like the ARL and other teams in the various countries, and then the AMSAT teams, AMSAT North America, of course, being absolutely critical in making this thing happen. Come on up here, Mark, because Mark and I are going to team tag on this a little bit. I just wanted to kind of show you all a little bit of what we've accomplished here. You know, we're at the 11th expedition now. We've had 10 different expeditions where we've trained crews, and they've done various operations on Space Station. We're at Expedition 11. I was going to let Mark say a couple words about our new crew here.
All right. As you see on the picture on the right, maybe a little bit back there, we have Sergei Krikalev, U5MIR, who you might recognize from the Mir days. He's also been on Expedition, which one was it? Expedition 1, and he was very active on ham radio then. And we anticipate quite a bit of activity from him on this mission as well. Also, John Phillips, KE5DRY, got his license just relatively recently for this expedition. He was convinced of the usefulness of amateur radio and is excited about doing school contacts. So we anticipate that he'll get on the air. We've also had very good luck once we get through a field day. A lot of the astronauts who, ham radio is okay and they don't mind doing school contacts, but they get the bug from field day and then they get really active. So we're kind of keeping our fingers crossed on that one.
Okay. We're developing the hardware in four main phases. We've got phase 1 on orbit, which is basically a portable station, handheld station capability. And then transportable is our phase 2, which is primarily like a mobile radio station. We're still talking about a permanent station. We're looking at how ISS evolves right now, and things are changing, and I think changing for the better. We have a new administrator in NASA now, and he's changing around how we're going to do things as compared to what you kind of heard in the past year. And I think you're going to see Space Station be a big cornerstone in the exploration initiative. So, and then a lot of external experiments, and actually we've got one that's going to be launched this year. We'll talk about that. Wanted to say a few words about where the equipment is. This is a real early picture of Space Station. Oh, thank you. The equipment is housed in the FGB, the Zarya, as well as the service module. Service module, if you look at the space station and the way it's constructed now, is the very end of the space station where Progress launch vehicles get docked to it. And so, I just want you to remember this because this is where the crew, habitation activities are. That's where they sleep. That's where they eat dinner and things like that. From a Phase 1 perspective, the equipment, as I mentioned, is in the FGB. The equipment is operational, I should say, primarily from a voice perspective. Bill Shepard on Expedition 1 mentioned that we have some of the best audio capability on Space Station, and the other thing to realize is that we've seen from some of the school groups that have done both ARISS contacts and have heard some of the contacts through the NASA TDRS system that our audio is significantly superior. Even though they get video on those, they really like the clean audio that we have. So we've got some of the best capabilities, and the reason for that is that we're direct. I mean, you've got to go through all these other channels through the TDRS system. On Phase 1, the packet system is not operational right now. We're using the one in the Phase 2 system right now. And we're waiting to install the 70-centimeter system in the service module. And then we've got a couple little pieces that need to be replaced, a headset and a headset extension cable. The extension cable is actually going on the next shuttle flight, the return to flight. So we've got that already manifested. Now, let me just say that extension cable is mainly for the 70-centimeter system, so it's not hurting us. It's our redundancy, if you will, our onboard redundancy that we have lost at this point. Mark, you're going to talk about the Phase 2.
The Phase 2 station, it's pretty much contained everything on the picture there. That is a folding laptop-type or suitcase-type system that was developed by the Russians to go on board. The green is all Velcro blankets, so everything is stuck to it so it doesn't float away. And you can see the Kenwood. Let's see. Kenwood's over here. The FT-100's there, and a bunch of cables and microphones. And we had a lot of help from our Russian partners putting this together. We helped integrate it and do some of the paperwork, but it really was a team effort to get this on board. The Yaesu's not up there yet. It will be flying hopefully sometime in the next year or so. But the D700 is our primary radio at this point. It's higher power, up to 25 watts. Eventually we'll get HF with the Yaesu once it gets up there. That'll be truly experiment because we're not sure how well it'll work through the antenna that's there. We're not sure exactly the ground plane of the service module where the antennas are mounted. So it'll be a true experiment to see what happens on HF. And we have packet radio and SSTV capabilities. At this point we'll be multi-band, multi-operator, autonomous, and crew-tended modes, just like it says at the bottom, so it'll be a very flexible system. This is a picture of the service module. This is where they eat, and the station is really close to it. Once we get it a little easier to operate and they get 3 people up there and have some more free time, it's in a really good spot to sit and just chat once they're relaxing. This is kind of where they relax when they're not doing experiments and keeping the station going. You can see the antenna cabling run through, and then on the outside is where the antennas are mounted from EVA. This is an end view where the Soyuz docks, right? On this end? Soyuz. So as they come up to station, they see a bunch of equipment, and for those who are hams, they'll see the ham antennas mounted, waiting to greet them, too. You can see it in some of the pictures from approaching the station and on the station. These are antennas that were, again, joint designed with the Russians, and we built a lot of it. We have a spacer to put it at the right height, a handle so they could do it during EVA. We have our main antenna, And then this is the L and S-band Glisser antenna that we actually share with the Russian Glisser system. That's their TV for EVAs. Again, it's a great opportunity. We got these out on board because the Russians needed this other capability, and ham radio went along for the ride. It was great. Okay. There's pictures of them mounted. If you look close, you can see the good key is the L and S-band antenna. On this side, you can see the longer whip antenna for us, for HF. And again, another view. This one's great because you can see all 4 antennas at one time. Here's a close-up of the antenna being deployed during EVA. You can see that there's a clamp and a handrail that it's permanently mounted to, and then the antenna runs off. Or I'm sorry, the antenna cable runs off to the side there. It's still folded up at this point, Velcroed together, standard steel tape. It's a good design, and it worked well for us too. Okay.
I wanted to mention that Mark and I are team tagging. I didn't mention Mark is now the U.S. team. He's my deputy in this program. The program has gotten so big because of the international flavor of it and the responsibilities and things that we've actually expanded our team another level to make sure that the day-to-day gets done. And it was clear that people like Rosalie White at the ARL needed to bring in some individuals in her group, and I needed to bring, from an AMSAT perspective, more individuals to support the technical activities. And so Mark is my deputy now that's been working this. With regard to, and that leads into the fact that in 3 years we're doing 3 launches. Back in 2003 we launched the D700 radio. Coming up in August, we've got slow scan television hardware, the new computer that we're going to be flying, which is an IBM A31, as well as some. Let me just say that the SuitSat stuff we'll talk about in a minute, but that's another piece that's going to be incorporated in. And in July of this year, our headset extension cable will go up on the shuttle return to flight. And then in future flights, we've got the headset for Phase 1 and then the Yaesu FT100 that need to be incorporated in. Mm-hmm. Okay. Just so you understand, we're operating this system in the service module with the Ericsson 70 centimeter, the Yaesu FT100, and then the Kenwood D700. And that's the 3 systems that will be in the service module once everything is operational for Phase 2 and Phase 1. The Kenwood has a number of operating modes. A number of you have used those, including voice, crossband repeater capability, packet, APRS, and then we have an emergency capability and an experimental 9600 baud packet system. Mark, you want to talk a little bit about where we are in Phase 2? Sure.
We have the D700 operating at this point using the antenna WA2, so we can operate on 2 meters and 70 centimeters, although we've been primarily operating at 2 meters at this point. Had fairly good luck with general voice QSOs. That depends on the astronaut and how much time they have. It's gotten a lot tougher since we're down to 2 crew members because they have to spend so much of their time just keeping the station going. As we mentioned, we've had packet. We have not had a computer available to tie into the radio for the crew to actually be active on packet, but we've had some digit repeating capabilities, some repeater operations, and a lot of school group operations, which is really what NASA is interested as far as their value out of the program, the education outreach, the incredible number of school children and general public that we reach each year for all of the operations. So just a couple more pictures on the future deployments for this August. We have SSTV doing space cam software going up on board, so we'll be able to take stored pictures from on board and send them down. They'll be able to see look in advance of what they're going to send down. We have the Yaesu that's going up. Another sister payload going up is PCSat-2 or MISSI-5, which is being done by Bob Verninga and the folks at the Naval Academy. He's using amateur radio to get some of his communications up to the package. They're coordinating with us to make sure that there's not a whole lot of, well, make sure there's no interference between the two systems. Anything else on that? Next, I'm going to talk a little bit about SuitSat. You want me to get started, or you want to?
Why don't you go ahead?
Okay. The Russians have to get rid of their spacesuits every now and then because they wear out. It's too expensive to get down, mass down from on orbit, so they kick it out as trash. We were approached with the opportunity to put some amateur radio equipment on board. The SuitSat will be kicked out and it lasts somewhere around a month or two before it comes in, and they're going to put enough batteries on there, should operate for 2 or 3 weeks. And you can see this is the Russian Orlan suit, and on top, drilled into the head, which causes some people consternation, is the antenna. We'll be mounting with a box and not quite drilling into that. They don't have that on board. But it makes for an interesting picture. Okay, you want to go through the details?
Okay, this is going to be kind of a cool thing because we're actually going to, this thing's going to get deployed in mid-September, and you need to understand something. This has been an extreme challenge for our team. We just a couple days ago got permission from NASA to go forward with this project, and we have to deliver the second week in June. So we have 3 weeks to deliver hardware. And we've been working on designs, and the biggest challenge has been the whole safety aspect of this thing. So we've been pulling all of this together. So we had a bunch of potential capabilities, and what I've done is I've put in yellow bold what we're actually going to have in this thing, which is a message downlink capability, which will be on the order of several messages that will get downlinked for people to listen to. You notice that SSTV is half bolded in yellow and white. We were going to have a camera on board, but it's just the short period of time we have to pull this thing together isn't going to happen. So what we're going to do is we're actually going to have a slow scan television image as part of the messages. So people will be able to pick up a slow scan television image that we'll have before we're going to install before flight. The other activities kind of have fallen off the table because of the short period of time. But another big thing we're going to fly is a DVD, basically, which, and this is for you all to understand and to bring out to your schools, anybody that has schools, is that schools are going to have an opportunity, if they have a piece of artwork that's like 8.5 by 11 sheet of paper, to put whatever they want on it, and we're going to scan it in, we're going to put it on the CD, and it's going to fly in the spacesuit. We're going to have the crew actually take a picture of them putting the CD in the spacesuit. So that's going to get deployed overboard, so the schools get to participate, if you will, in a spacewalk. So we have information on this at the AMSAT booth, a little one sheet of paper. It's also been out on AMSAT BB if you haven't seen it yet. If you've got schools that would be interested, we got a real short turnaround on this, because we just got permission and we got to get everything done by mid-June. Mark's got a couple things he's going to show you relative to the actual SuitSat. Here's a little demo of the PIC module that the Tapper team, Steve Bible's group, Steve's around here somewhere, there he is in the back, has been working on. Go ahead, Mark.
I got to put it right. Now, obviously, this is going to be wired in electrically, but see if you hear it over the microphone.
25 degrees Celsius.
Can you hear that at all?
Yeah.
Okay. So they'll be using that to get some of the telemetry on board. And let me get over here from the microphone real quick. We're using a Kenwood THK2 is the main radio. You take the antenna off. These are great radios once I finally got to look at it. Let's see if I can do this again. But we're going to be taking the battery off because we're using other batteries. And this is really all that's left of the radio that we're going to fly. This clip will be off, and this will be mounted in a box. So this is flight hardware, so to speak, we're taking off the shelf. It's a 2 or 3 week operation, so we don't have to go through all the normal things that we would normally do to make sure it lasted long term. So it's kind of neat to have that hardware. We just picked it up and going with it. We've gotten great support to get everything put together. Lou's done a good job of crafting together what we have on hand to deliver in 3 weeks. So that's Lou McFadden. He's over there, W5DID.
Okay, and we're going to be operating this thing on 145.99 downlink, so look forward to hearing it. Okay, just real quickly, our operations primarily are 145.80, and you all can get this stuff on the AMSAT website. Don't hesitate to look there for it. Emily's done a great job of pulling all this stuff together. From a perspective of Expedition 10, Leroy Chiao did a phenomenal job with schools. He did a record of 23 schools for us, and we're up to about 180 schools actually at this point now since the beginning of space station activities. Did want to put a plug in that we put a plug in for AMSAT as much as we can on every one of these school contacts, as you can see here. This was a school in California back in April, and you can see the phenomenal number of students in the room for this thing. They filled the place wall to wall. We get a lot of a lot of visibility. AMSAT and the whole ARISS program gets a lot of visibility. About 15,000 students a year are touched by this program directly. We have about 1 million people, several million people last year, about 6 million, I think, that witnessed an aspect of this program, either through the IMAX film that has a student contact on it or through a direct amateur radio contact. Did want to mention we're extending beyond where we are today with voice over internet protocol. Dieter, who's been at the booth all weekend, has been honchoing the whole Echolink activity, as well as we have Wayne in Canada that's honchoing the IRLP activities. This information is available on, if you go to the AMSAT website and go to calendar of events, Dieter's done a good job of making sure that things are on the web and that you can have access. This gives you all an opportunity to bring a school in or bring your friends in to hear a school contact, both sides of the contact, the downlink and the uplink. Okay, and then for Expedition 12, we've got a lot of different things going on. We've got random... Bill MacArthur is a ham's ham, so I want you to be aware of that. He's going to fly in October, and he is planning a whole lot of ideas. He wants to do a lot of schools. He wants to do a lot of things, both experimental as well as operational. So look forward to Bill being on board. He was great on his last flight. He used the mirror equipment on his last flight to talk to people around the world, and he will be very active. Okay, I wanted to say a couple words about the vision. Back in a little over a year ago, the President signed a policy to extend NASA's reach from low Earth orbit to the Moon, Mars, and beyond. And we're working heavily with NASA and trying to develop an architecture that's going to take us, not only keep us on space station, but to go beyond that. And so what our new administrator, Mike Griffin, who is a ham radio operator, by the way, is changing things around in NASA, trying to expedite the development of the crew exploration vehicle, which will help retire the shuttle faster. The crew exploration vehicle he wants to have the ability to hold 6 people so that then we can extend our abilities on space station. In other words, have 6 people on space station. And then ultimately, that exploration vehicle will be used to go to the Moon and Mars. So things are changing, and changing for the better, and we're doing our best to be involved in that activity. And we want people to keep thinking about what kind of ideas, and if you've got ideas on what we might want to do, come see me, Lou McFadden, Mark Steiner, Rosalie White, on ideas of education, on hardware, all kinds of different things. So the time we need to do this is now. And I want you to really think about this hard. And if you're interested in helping on this or anything else from a volunteer perspective, we need lots of volunteers, just like the whole AMSAT community needs lots of volunteers to do our jobs. So in conclusion, I want to say that we've got hardware on board space station that's fully operational. We're continually evolving that to more and more capabilities. We're getting crews that are becoming more involved in the hardware, like Mike Fink was this last 2 expeditions ago. And we're positioned to go beyond Earth orbit, and we want you to help us make that happen. Thank you.
This has been another edition of the AMSAT Newsreel.